Hello.
Yeah.
Am I audible?
Yeah, you're audible.
Okay.
Your desktop, and you can maximize this.
Okay, so we can start, right?
Yeah, we'll have a small brief introduction from founder of our IABSC. He's joining us from Netherlands. So we'll just have a brief introduction of you from his side, and then he'll hand it over to you, and you can start your presentation. Is that fine?
Absolutely.
Just a moment.
I'm very happy to announce to you one of the world's most respected speakers on the subject of artificial intelligence, data science, and quantum strategy, Mr. Utpal Chakraborty. He's Chief Technology Officer at Intel AI Neotech, formerly Intel TI Technologies, and responsible for the research and development of cutting-edge AI and quantum solutions for various industries and domains. He has more than 2 decades experience in all aspects of AI and quantum development with leading organizations such as L&T, IBM, Capgemini, and JetBank. Utpal does not only know what he's talking about, but is recognized internationally for his presentations and the books he published on this subject. Many institutions honor him with awards and ambassadorship because he is sharing his message in such a clear and understandable way. Next to that, he takes into account the social aspects, the role of women in our working world, and animal welfare. He even touches some spiritual issues in his ideas. In short, I'm excited to announce the next speaker, Utpal Chakraborty. Utpal, the floor is yours.
Thank you so much. And thanks everybody for joining this session. I think thanks for a very good introduction. So we'll go to the presentation. I've got a couple of slides, and today we are going to discuss the enterprise adoption of generative AI, because generative AI is essentially in a couple of months, I think it has taken the entire world into storm, and everyone is talking about generative AI and large language models, the LLMs. But what is the enterprise adoption of generative AI? Like whether already we have started using generative AI as a co-pilot kind of a mode, or we have already started building many applications of generative AI. What are some of the challenges, and what are of course, there are many opportunities that generative AI brings. So we are going to discuss that. So I'll not go into all the slides, but very quickly we'll go into. So I think almost all of us are aware that what is generative AI. Okay, in a very high level definition, these models are generative models, also called generative transformers, because this is a neural network, and the type of neural network is a transformer neural network. And the beauty of these models are it can generate fresh content. Okay, so it is not a cut, copy, and paste from somewhere. No, the models have been trained with huge amount of data, and now the models have got some kind of intelligence. It has also got a memory map, and it can generate fresh contents depending on what kind of a query or what kind of a question that we ask to the model. And this content could be text content, it could be image, it could be audio, it could be video, or tomorrow, I don't know, probably something else. Okay, but right now this is the scope, and that's why it's called multimodal. Uh, the main difference between the predictive models and the generative models are predictive models are mainly used for doing any kind of prediction, okay, future prediction. But generative models are more uh, applied when we need to create some content. Okay, so this is on a high level. Now there are various variants of generative models, so let's not go into that technical, but just for understanding. Uh, and these are some examples, and I think everybody knows now, right? I mean, this slide is not that relevant, but still then, so these are all model generated images and also the sample code, right? So the model can essentially understand the stereotypical patterns of Indian brides and grooms of different states, and it can generate the images of the brides and grooms, okay, from its intelligence. And this is nothing that has been uh, copied and pasted here, right? This is completely generated by the uh, generative model, very fresh content, okay. And I think to a great extent, it has done a very good job, okay. So it has at least been able to identify the patterns, the stereotypical patterns of the different traits or the different uh, 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 states of India, right? So this is an example. Similarly, generative AI can also uh, create the picture of a child, okay, how it should look like, he or she should look like, by analyzing the images or photographs of his or her parents. Okay, so this is kind of a uh, power that generative AI brings, right? So this is again image synthesis kind of a thing, and you also see a piece of code. Okay, so this piece of code actually I have told GPT 3.5. It is not GPT 4 that please create a control system for Chandrayaan. I think most of you know what is Chandrayaan. Chandrayaan 3 was a mission to the moon by Indian Space Research Organization. And very soon it was successful. So Chandrayaan 3 actually landed into moon. So I told just how to create a control system through which we can actually create the speed of Chandrayaan 3. And it has given me a pseudocode, although this is not a code that can be used in Chandrayaan. Okay, but I think it has done a decently good job. It has understood. Okay, so now this is the state of generative AI today. Now you can imagine in the coming 5 years, okay, or 10 years, where the world is going to be, okay, with generative AI. Okay, and this is not just a hype, this is very, very real. Now, to understand generative AI or how the neural network works, I think we should understand how human brain works. So let me very briefly, so probably I'll be taking a minute or two to give some kind of a context how human brain works, because the entire artificial neural network is being inspired by human brain. So in a human brain, in an adult human brain, there are around 100 billion neurons. Okay, and these neurons are some special types of cells. It is a little bit bigger than the other cells in the body. Also, these cells are little bit negatively charged, around minus 50 microvolt negatively charged compared to its surrounding. And also these cells work in a very uh, interesting and strange manner. What it does is whenever the electrical signal falls into this kind of cells, actually the potential difference within the cell starts getting increased. Okay, and when it increased to a particular threshold limit, the electrical signal is to be fired from one cell to the another cell through a wire-like structure called synapse. Okay, so let's take an example of our visual system. So normally, as we understand, like our visual system works like when we see an object, the light rays or the photons from the object, light photons from the object comes to our retina, okay, and then it straight goes through the retina and falls into something called visual cortex. Now, the main function of visual cortex is to convert the light signals or the photons into electrical pulses, electrical signals. And once this electrical light rays are converted into electrical signals, these electrical signals falls into the different layers of neurons. So the neurons in our brain are arranged in a layered manner, right? And there are millions of layers because, as you can imagine, there are 100 billion neurons in the brain. So there will be many, many layers of neurons. Now, when this electrical signal, which is coming from the visual cortex, falls into the first layer of neuron, what happens is how each individual neuron uh, uh, behaves is whenever this electrical signal falls into the neuron, a special phenomena starts happening. It is similar to the photosynthesis that happens in the leaves of the trees. This phenomena is called protein synthesis. Okay, and due to this protein synthesis, what happens? The potential difference within the neuron gets more and more and more. Okay, it increases, and it reaches a particular threshold limit at which the neuron cannot hold that electricity. So what it does, it fires that electricity to the next neuron. And these neurons are connected with something called synapse. These are wire-like structure through which electrical signal can pass. Now, as we know, when the signals are passing, along with the signal, we are also passing the information, right? So if a child probably the first day he looks at an elephant, okay, and the same phenomena happens. The light signal from the elephant goes through his neuron, through his retina, and then falls into the visual cortex. In the visual cortex, the light rays are converted into electrical signals, and then falls into the first layer of neuron. Okay, uh, the potential difference goes up because protein synthesis starts happening, and it fires to the next layer of neuron. In that way, the information is also passing from one layer to the other layer of the neuron. Okay, so that's how the information is being processed within the brain. And at a particular layer, okay, so probably after 1 million layers or 2 million layers, there will be a decision-making layer wherein what it is going to do is it is going to actually identify what exactly that object is. So this is the process, okay? And what we do is the same thing we are trying to do in our semiconductor, and that's how the artificial neural network came into picture. In the artificial neural network also, we sent input information through various layers of neurons. Okay, and these neurons are actually, you can say, mathematical neurons built programmatically, and this information is processed layer after layer, layer after layer, and at a particular layer, we take a prediction or a decision, right? There are various other things also. Now, if you look at the evolution of neural networks, so one neural network which was very, very popular and which was very, very successful was convolutional neural network called CNN. Okay, so convolutional neural network uh, is responsible for doing any kind of image processing, video analytics, a lot of things, anything to do with image, video, and all. I think convolutional neural network is one of the choices, right? And it was pretty good at that. But then we also have another problem, which is called essentially the language problem. Okay, how to deal with the language and text. Okay, because hey, language is a very complex phenomenon. Okay, language has no standard rules. Okay, although we have got grammars and all, but language processing is one of the most difficult thing, uh, uh, and it is really very difficult to do that. So then, to solve language-related issues, we try to come up with another neural network, which is called RNN. Okay, recurrent neural network. It was decently good in terms of processing small amount of text, but it has got some very fundamental limitations, which is called vanishing gradient and exploding gradient. Just to give you an example, vanishing gradient is kind of a child. Okay, so normally if you look at how human learns or how a child learns things in a very gradual manner, slowly. Okay, so that's why our education system is like that. Okay, so we have got different classes. Okay, so if you want to teach a child, okay, so master degree kind of a or postgraduate kind of a book in the first day, you'll not be able to understand, right? So same thing goes for the neural networks also. It learns slowly and gradually. Now, what happens in recurrent neural network? Uh, Due to vanishing gradient, this is a fundamental problem. So the network at one stage, it is not been able to learn anything. Okay, it learns for some time, and after that, the curve becomes flat, so it is not actually learning anything, right? Like a dull child, right? And there is also another problem. Sometimes what happens, it pretends to learn a lot of things. Okay, so the curves becomes like this, but actually it is not learning anything. It is like some kind of a very open smart child. Okay, so they act like they are learning a lot of things, but ultimately actually they are not learning anything, right? So because of these two fundamental problems, recurrent neural networks were that uh, not that good in solving many of the problems, especially the language related problems. Then we come up with another neural network, and this was a very popular neural network, by the way. Okay, and most of you probably have used this neural network very extensively unknowingly. Okay, so because it is there in the Google Translate, it is there in any kind of text processing. Even many of the search engines are also using this kind of thing. So a lot of places. Okay, last 10 years, there has been a huge use of this particular neural network called LSTM. Okay, so this is long short-term memory. This neural network was able to solve the problem of vanishing gradient and exploding gradient to a great extent. And this neural network was also decently good at learning a large amount of data. Okay, so when I say large, not very large, large amount of data. But again, okay, although this was a very successful neural network, but it has got also a little bit of problem. Okay, and what we have envisioned, like to build a model which is like super intelligent. Okay, so this was not fitting into that criteria, right? So then we come up with something called generative transformers. Okay, so generative transformers are actually a very powerful neural network. Okay, it can learn a lot of data. So I think you can train it with trillions of parameters. Okay, even then it can learn, right? So this is kind of a revolution that these transformer neural networks or generative transformers and brought into the table, and that's how you see ChatGPT, Google Bard. There are a lot many other models available in the market, right? So some of them are public models, some of them are models, foundational models that you can use it for your own purpose. You can retrain, you can fine tune, and you can do that. So this transformer neural network is kind of a revolution in the industry, but that's not the end of the story. Okay, and this neural network was actually developed or formulated by some of the researchers of University of Toronto and Google, right? So these research papers are also available in the internet. But that was not the end of the story. Even Transformers has a little bit of problem, okay? And that problem was then been solved by this gentleman and this lady. These are the people from different companies, from different background and they jointly published a research paper, okay, which is I think one of the revolutionary research paper, at least in this decade, okay, in the field of artificial intelligence. The name of the research paper is "Attention is All You Need." Okay, so this is the name of the research paper. Attention is all you need. Now, very briefly, what this research paper tells is essentially in a generative transformer, you train it with trillions of parameters, it becomes very, very bulky. Okay. Right now, how actually to hold the long-term relationship of sentences or paragraphs or of words and all other things, how to bring out all this information from the gigantic bulky model. Okay, so this attention model, so these are also neural networks. Okay, so these are substituted neural networks and techniques. This helps in generating responses lightning fast when you type a question or a query to your ChatGPT or your Google Bard. Okay, it can bring information from all across the intelligence that has been built into the model, okay, the gigantic model, and bring it to you within a couple of seconds probably, or at max a minute, right? So this is a revolutionary paper and thanks to this gentleman and the lady. Now, so these models are also called large language models, okay, because they are mainly used for language purpose. But having said that, I think it is better to call it now as a generative model because it not only solves the language problem, it also solves the other problems like images and all those things. So you can see the DALI model, which has been integrated with ChatGPT, now can generate image. Okay, if you have ChatGPT 4 subscription, then you will have also DALI, which can generate beautiful images, right? And ChatGPT is actually a architecture, or GPT is architecture, and there are many other models actually that are working behind the scene. One of the very popular model which has been used for building applications and all are GPT Turbo, right? So GPT 3.5 Turbo is one model which is very, very popular and which can be used for building a lot of applications there. I'll not go into the how the models are being trained, but just to give you an idea, it has been trained with huge number of data. Okay, and it is almost everything that is available in the public internet, right? It could be wiki articles, it could be research papers, it could be social media interactions, and a lot many things. Okay, so the models are now being equipped with all type of uh, ideas, all type of knowledge of all subjects. So these are some of the models that OpenAI provides. Prompt engineering, as we all know, like prompt engineering is something how efficiently we can interact with a generative AI model. So there are some techniques to be used to do that. Okay, and this particular subject is called prompt engineering. Okay, and there are various kind of prompts available, like manual prompts, automated prompts, task specific, adaptive prompts, ethical prompt. Lot many prompts are there. Okay, and if you know these techniques, then you can get best out of this generative models. Okay, otherwise, if you ask a very generic question in a very generic way, you will also get a very generic answer, right? But there are techniques. Okay, the prompt techniques, if you can do it well, then probably you will get the exactly what you are looking for for the model. Now there are also many hyperparameters with this model, and you can actually change the hyperparameters and actually make the models much more creative, make to answer when it is answering. Okay, you can make it, you can actually tweak the model as per your need. Okay, if you know how to tune these hyperparameters. Now coming to our exact topic, or the topic of discussion is basically enterprise adoption. Okay, so if you look at, definitely generative AI has moved out of experimentation to the industrialization. Okay, that we have already seen, right? There are now, if you search in the internet, you will find hundreds of applications of generative AI. Already people have started building. In fact, we have also started, we have already built and sold also a product in the market, in the big enterprises, government enterprises. Okay, so it is already in the industrialization phase. So now, what is the industry trend? These are some of the observations that I have found during couple of months. During last couple of months. So number one, there is a huge interest in investment on generative AI. The interest in investment has increased by 70%. Okay. In the industry or the enterprises, still people are discussing the right use case for generative AI, where they can actually use the generative AI for the enterprise grade, for building enterprise grade applications. Okay. And there are discussions whether they will be building some applications for themselves, or it is going to be a customer facing applications. Okay. So internal application or customer facing applications. There are also discussions which are happening in terms of what kind of a model they are going to use, whether they are going to use a public model which are easily available and you can just consume the API and you can build an application on top of that, or you are going for a foundational model and fine tune it. Okay. Then also a lot of copilot things are already happening. Copilot in the sense already you are using a lot of enterprises are using ChatGPT, Google Bard, and this kind of models, or probably some other model for doing a lot of things, which is kind of a co-pilot. Okay, it is helping. Generative AI is helping to perform their task better in a much shorter time, right? And I think everyone is now doing it. Also, there are discussions going on in terms of ethical aspects and also regulatory and compliance related aspects of generative AI. Okay, so this is on a high level what is going on in the industry, what people are discussing. Now, what are the expectations of any enterprise, okay, on generative AI? Okay, so this generative AI revolution has brought a lot of hopes, but ultimately, what are the expectations that industry have with generative AI? So industry or the enterprises are looking at the right use case. They are also looking at a model which should be in their control. Okay, they don't want the model to be somebody else's control. Okay, they want it to be in their control. So that is very, very important. They are also thinking that how to train, because to train or retrain a model, foundational model probably, or to train a fresh model, you require a lot of high quality data. Now, how to get that high quality data? Some of the enterprises probably they have. Okay, some of the enterprises they don't have. Probably they will have to source that data from somewhere. So this kind of expectations and discussions are already happening. Now, developing model from the scratch and training it is a costly affair. Okay, and industry uh, leaders are cognizant about that particular fact. So they are also thinking of that. The major concern with generative AI is the security aspect of it. Okay, so there are a lot of discussions that are happening how secure it is, to pass information, sensitive information to a generative AI for processing. Okay, even if it is a probably the offline model, okay, within the premise of the organization, but still then how safe it is. But probably it may leak the information to some other audience, even it is internal, okay, who are not actually intended to be disclosed. What kind of a governance model should be there in this generative AI landscape? Okay, so that is also one discussion and expectation that is having the leaders of the industry, right? And also auditability. Of course, if you have such kind of a model implemented, especially for financial sectors, which is a highly regulated sector, then are those models going to be auditable model? Okay. So these are the expectations or discussions that are going on in the industry. Now, applications of generative AI can be actually categorized into when we talk about enterprises, by the way. So now we are talking about enterprises. Of course, public models are available for public normal general purpose uses. You have got a lot of models and you can do whatever you want. But when it comes to enterprise uses, then the applications are actually divided into two types of application. One is customer facing application and the other is the internal applications. Now, the problem with the customer facing application is the major issue is the hallucination of the model and also the toxicity of the model. So as you all know, many times these generative AI models hallucinate. And when it hallucinates, it may give you improper information, improper, it can generate improper content. Okay. Improper in the sense it could be inappropriate or it could be wrong. Okay. So this is hallucination on a high level, of course. There is a definition of hallucination. And also toxicity. We should also see that generative model should not generate toxic contents. Okay, this is also something we should be careful about. Okay, so if the generative AI model starts generating toxic contents, then it is more harmful than its usefulness. Now, extraction of information from a large amount of unstructured data is something already people are trying. Okay, so this is more kind of a generative AI analytics kind of a thing, and it is already been in use. Many companies are using for large amount of email classification, auto responding, etc. Analytics. People are already using. I have also seen some applications there. Some people are building universal chatbots. Okay, these chatbots are essentially it's a multi-model or you can say multi-domain chatbots. Okay, so you can actually hold the context of different kind of conversations and different kind of topics. So for example, the single chatbot can actually answer or can serve the different types of requirements in the financial industry, right? So, I mean, usually it used to be some specialist chatbots, right, for a specific kind of a need. But with generative AI, as it has got some general understanding already, so the universal chatbot kind of a concept is now getting a lot of traction in the industry, and people are building it one chatbot for all purpose. Okay, and internally it will handle everything. GenAI for testing services, people have started trying it out. Okay, it can write very good test cases if you can tell it uh, the requirement. It will generate very high quality test cases. So that is also done. Now, there are discussions around base versus fine-tuned models. Okay, so I'll not go into that because this is again, but yes, so this is the technicality of the thing, whether you take a base model from or a foundational model from somewhere and then you do RLHF, which is nothing but reinforcement learning with the human feedback, okay, to make it fine-tuned and then use it for your purpose. Um, uh, kind of things are also in discussion. Okay, so let's skip this. Okay, how to do this and all. Generative Copilot. So generative Copilot is something which is already, I think all of you are already doing, right? At your job or at your home. These are like all knowledge-based industry, right? So they are already using it for generating content, okay, and summarization, text summarization, reports, doing some kind of analysis. So this kind of co-pilots are already happening. In the media and entertainment, in the media and entertainment world, already some of the contents are being generated, okay, and they are also using it for some moderation of the contents. Insurance industry also people have started using it. It is co-pilot, by the way. These are not applications. Okay, this is using those models uh, to make your task easier or better or more efficient, kind of a thing. Similarly, on the finance, okay, so in insurance, like for claim investigation, if you have something and you give that information to the generative model, it can do a better job, right? And it can also help you in underwriting, in finance, asset allocation across various portfolios for the wealth management. Okay, that also generative AI can do a very good job, okay, sometimes because it has got those understandings. Uh, Generative Copilot for projects, people are using for everything, starting from writing the requirement to from translating the requirement to SRS software requirement specification, then creating a draft project schedule by the generative model, then high level estimation of the project, use cases document, then in the stories or kind of thing, design document, building test cases, okay, requirement testability metrics, building, and so on and so forth. Okay, generative models are but these are all co-pilot examples. Okay, so some researches are going on at MIT to create some small size models which requires very small amount of data to be trained, and it will have the similar kind of a performance like the gigantic models. I think if this things comes out soon, I think there is going to be another revolution in this industry, because now the limitations are the size of the model, the infrastructure required to train the model, and the amount of data that is required for training the model. Okay, so these are the challenges. But once this kind of a model, if scientists can bring, which is already going on, the research, I think it is going to bring another revolution in the industry. Lightweight, small generative AI models, which is equally powerful as these big gigantic models, right? So generative AI and risks, this is very important to understand. I think we'll not go into detail because that will take another 4, 5, another 2, 3 sessions probably. But so there are three types of risks involved for generative AI. One is security risks, another is ethical risks, and the other one is operational risks. Okay, so we need to understand that and how to mitigate that. There are ways to do that. Okay. Another area also we need to look at is the bias. Okay. So the bias can come from, and I think all of you are aware of that. If the model gets biased, then I think it's a huge uh, risk and it is a huge challenge, right? And the bias can come from many factors or many things. Now there are also risk frameworks, right, that can be used to minimize the risk of your generative AI. And by the way, this is not only for generative AI, for any other AI applications that you are building. I think you can do uh, this kind of a risk framework, and to at least to do at least you can do a check that whether there are uh, risks involved and how to mitigate those risks. Okay. So there are also frameworks, there are also best practices available. It is up to you, okay, if you want to use it, and I would suggest definitely you should use in your organization, okay, because I mean every technology, every powerful technology like generative AI brings a lot of advantage, but at the same time it also brings a lot of danger, right? So it is almost like nuclear. So how you use it, okay, it is up to you. But these best practices and frameworks are already given, right? So starting from your training data to a lot of ways that your data got poisoned, either by your internal people or some attackers from outside. Okay, data poisoning is one of the thing which is a great risk for this thing. Prompt injection, okay, is another risk that people may use very sophisticated prompt, okay, to attack your model and get some information out, okay. And a lot of other attacks are also they are like adversarial attacks and all these things like that. So there is a form framework called NIST framework. You can refer. It is not very exhaustive. I think, I mean, for generative AI, definitely you require more than what has been mentioned in this framework, NIST, National Institute of Standards and Technology, and everything. But you can follow that. Many of the things have been covered here. Okay, for any generative model, when you want to deploy it in your enterprise, you need to do a rigorous testing. Okay, testing is key to success. Okay, and there are various types of tests that need to be performed before actually you release the services of your model to either to your customers or to your internal stakeholders. So this is a must. Yeah, I think uh, that's all. Uh, if you have any questions, then uh, I can probably uh, address that.
Yeah, thank you so much, Utpal. Yeah, we do have some questions, like, I think a couple of them at least, which talking about the ethical side considerations, and I think that itself is a separate topic. And then the other one is potential risks. Yeah, I think you covered that. Pawan Kumar wants to know what kind of computer skills do you think which won't be replaced by generative AI in general? That's a question from Pawan.
Yeah, so it is not repressing actually, because these are more of uh, substituting rather than replacing kind of thing. Because I firmly believe that human intelligence or human skills cannot be completely replaced, right? But yeah, definitely it is an automation ultimately, okay, and you can say it is an extreme automation, okay. So definitely it is going to take away uh, many jobs, and it is already doing. However, it is not kind of I think for any automation that you do, right? So if you go back to our industrial revolutions, one, two, three, four, right? Everywhere, wherever we put a machine, some people have lost their job. But at the same time, probably many people have got a lot of opportunities. Okay? And also the job profiles of human has elevated to a different level now. So I think human jobs will be much more intellectually challenging jobs rather than mundane, low skilled or repetitive kind of things, because these things can anyways uh, can be given to machines, right? But to answer your question, yes, anything and everything, because now it has got human intelligence, that cognitive element, right? So it can, I mean, in that way, it can write a very nice contract, okay, which normally a specialist or a lawyer is to do, right? But that doesn't mean that you can just rely on the contract written by the generative AI, right? Still, you need one person to validate it, okay? But probably 90% of his job has been done, automated kind of thing. So look at it from an automation angle, an extreme automation. This is an extreme automation, okay? So definitely it has got a huge impact, but it is not just replacing. Okay, it is actually helping. So that's how I can at least answer. I don't know whether it's a satisfactory answer or not, but I tried my level best.
Yeah, there's one question from my side also. Well, like, recently at the World Economic Forum, I think the Mr. Klaus Schwab actually said that now that we are using a lot of predictive models, now it can move over to becoming prescriptive models. And going forward, he actually made a mention of saying that going forward, even prescriptive models can be used and can be replaced. You can replace governments, and you don't need elections, and it's already getting there. So, I mean, I say kind of sounds scary as well in terms of, like, where how far they're going to take this.
No, I think that is not going to happen. Uh, that is not going to happen because I mean, that is again a different topic altogether. But AGI, artificial general intelligence. So I mean, going to that level actually requires a lot of breakthroughs in the current research that we are doing with AI, right? So right now the AI that we are doing is not at that level. Okay, so I mean, generative AI may be very, very fascinating. It is only because it has been trained with huge amount of data, and it has got that knowledge, right? But at the same time, it has never been autonomous. Okay, because autonomous is a different characteristics. Okay, which is the intrinsic property of universe, which cannot be transferred to a machine, at least for now. Okay, autonomy, the full autonomy that we talk about. So essentially what we are talking about is the autonomy of the machine. Okay, so there are many questions like, I mean, robots are becoming autonomous or AI is becoming autonomous. Full autonomy requires a different dimension altogether, right? And that is not coming from that nature of research right now going on at different universities and different research centers, right? So that requires a different approach altogether. Also, we are not sure whether that is possible or not, because uh, that's essentially the intrinsic property, okay, of of the nature, and that cannot be transferred to a machine.
Yeah, you mean artificial general intelligence?
Yeah, more than that, the autonomy. Okay, because people are fearful about the autonomy of the machines, right? So it's fully autonomous and it can do anything and everything. No, that is at least the researches that are happening right now. It's not possible.
Thank you so much, Utpal. Actually, we are overshooting. Actually, this is such a vast topic to discuss. I don't think 40-50 minute session would suffice. But thank you so much for taking your time out and showing your insights on what we have in store for the days to come. And yeah, thank you all for joining the session. And this session was sponsored by IABAC, the International Association of Business Analytics and Certification. And please follow us for the upcoming session, and visit our website at iabsc.org, and follow us on all the social media channels, and we'll keep you posted on the upcoming sessions in the coming weeks. And thank you again, Utpal, for taking your time out. I know you're busy with with quite a few things now, but then thanks for taking time out for us. And thank you all for joining. And Have a nice day. Goodbye.
Thanks. Bye.